Hello students, welcome to lecture series of Mathematics 1. This is Hitesh Maclaurin, Assistant Professor at LG Institute of Engineering and Technology. Today we will discuss about Maclaurin series. So in the last lecture we have discussed about Taylor series. So Taylor series of function f of x is given by f of x is equal to f of a plus x minus a raised to 1 divided by 1 factorial f dash a plus x minus a whole square divided by 2 factorial f double dash a plus so on, and nth term will be x minus a raised to n divided by n factorial f n a plus so on. Now if we replace a equal to 0, if we put a equal to 0 in this Taylor series, then we will obtain Maclaurin's series. So here f of x is equal to f of 0 plus x minus 0, that is x, divided by 1 factorial, and value of 1 factorial is 1, so no need to write down. X into f dash 0 plus x square divided by 2 factorial f double dash 0 plus so on plus x raised to n divided by n factorial fn 0 plus so on. So this is Maclaurin series, and using Maclaurin series we can express function in ascending powers of x. Now we will discuss Maclaurin series of standard functions. So here we will have to discuss Maclaurin series of function e raised to x. So here first of all we will have to find out value of f of 0. So here replacing x by 0, so value of e raised to 0 is 1. Then taking derivative of f of x, so we will have to take derivative of e raised to x, and derivative of e raised to x is e raised to x, and here replacing x by 0, so it will be e raised to 0 and value of e raised to 0 is 1. Now again taking derivative f double dash x, so derivative of e raised to x is again e raised to x, and replacing x by 0, so here it will be e raised to 0 and value of e raised to 0 is 1. Now taking derivative again f triple dash x, so derivative of e raised to x is again e raised to x, and replacing x by 0, so here it will be e raised to 0 and value of e raised to 0 is 1. So and so on, because if we take nth time derivative of function e raised to x, then it will be e raised to x. Now by Maclaurin series, what is Maclaurin series? It is f of x is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash 0 plus so on, plus nth term is x raised to n by n factorial fn 0 plus so on. So here what is f of x? It is e raised to x, and our value of f of 0 is 1 plus x into f dash 0, value of f dash 0 is 1, so here we will write down 1 plus x square by 2 factorial, value of f double dash 0, it is 1 plus x cube by 3 factorial, value of f triple dash 0, it is 1 plus so on, and nth term will be x raised to n by n factorial, and value of fn 0 will be 1, because as we have discussed earlier, nth derivative of e raised to x is e raised to x, and if we replace x by 0, then fn 0 will be 1. So this is Maclaurin series of e raised to x, 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on, plus nth term will be x raised to n by n factorial plus so on. Now we will discuss second function, that is e raised to minus x. So here we will have to find out Maclaurin series for e raised to minus x. So we can find out Maclaurin series for e raised to minus x by same method. So here first of all we will find out f of 0, then f dash 0, then f double dash 0, and same procedure. But here we have already found Maclaurin series for e raised to x. So we simply replace x by minus x. So here if we replace x by minus x, then it will be 1 minus x, then here minus x whole square, and value of minus x whole square will be positive. So it is x square divided by 2 factorial, then minus x whole cube. So minus x whole cube will be negative. So here it will be negative minus x cube by 3 factorial, then positive x raised to 4 by 4 factorial, then negative, so on. So this is Maclaurin series for e raised to minus x. Now let us discuss Maclaurin series for hyperbolic function. So first function is cos hyperbolic x. So cos hyperbolic x is defined as e raised to x plus e raised to minus x divided by 2. So as we have already discussed, Maclaurin series for e raised to x is given by e raised to x is equal to 1 plus x raised to 1 by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial plus x raised to 5 by 5 factorial plus so on. And Maclaurin series for e raised to minus x is given by 1 minus x raised to 1 by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial plus x raised to 4 by 4 factorial minus x raised to 5 by 5 factorial plus so on. So here, now adding these two series, so we will have to find out e raised to x plus e raised to minus x. So here this is equal to, if we add these two series, then here as you can see, plus x raised to 1 by 1 factorial minus x raised to 1 by 1 factorial. So these two terms will be cancelled out. Same way here, plus x cube by 3 factorial and minus x cube by 3 factorial. So these two terms will be cancelled out. And plus x raised to 5 by 5 factorial minus x raised to 5 by 5 factorial. So these two terms will be cancelled out. And here 1 plus 1, so this term will be doubled. Same way x square by 2 factorial plus x square by 2 factorial, so this will be doubled. Same way plus x raised to 4 by 4 factorial plus x raised to 4 by 4 factorial, so this will be doubled. So directly we can write down 2 common in bracket 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus so on. Now dividing by 2, so if we divide by 2 both sides, so e raised to x plus e raised to minus x divided by 2 is equal to 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus so on. So this is what it is, cos hyperbolic x. So we can replace e raised to x plus e raised to minus x divided by 2 by cos hyperbolic x. So this will be cos hyperbolic x is equal to 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus so on. So this is Maclaurin series of cos hyperbolic x. Now we will discuss Maclaurin series for function that is sin hyperbolic x. So here sin hyperbolic x is defined as e raised to x minus e raised to minus x divided by 2. So we have already discussed Maclaurin series for e raised to x is given by 1 plus x raised to 1 by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial plus x raised to 5 by 5 factorial plus so on. And Maclaurin series for e raised to minus x is given by 1 minus x raised to 1 by 1 factorial plus x squared by 2 factorial minus x cube by 3 factorial plus x raised to 4 by 4 factorial minus x raised to 5 by 5 factorial plus so on. Now we will have to find out e raised to x minus e raised to minus x. That means we will have to subtract these two series. That means we will have to subtract e raised to minus x from e raised to x. So if we subtract these two, then here 1 and 1 will cancel out because sign of all these terms will be changed. Here it is plus, then it will be minus. This will become plus, this will become minus. Plus, minus, plus, minus. So 1, 1 will cancel out. Same way here x square by 2 factorial minus x square by 2 factorial. So this will be cancelled out. Same way plus x raised to 4 by 4 factorial minus x raised to 4 by 4 factorial. So this will be cancelled out. So here plus x raised to 1 divided by 1 factorial and plus x raised to 1 by 1 factorial. So it will be doubled. Same way here plus x cube by 3 factorial plus x cube by 3 factorial. So it will be doubled. And here plus x raised to 5 by 5 factorial plus x raised to 5 by 5 factorial. So it will be doubled. So here taking 2 common. So in bracket it will be x plus x cube by 3 factorial plus x raised to 5 by 5 factorial plus so on. Now dividing by 2 both sides. So e raised to x minus e raised to minus x divided by 2. Here it will be x plus x cube by 3 factorial plus x raised to 5 by 5 factorial plus so on. Now this is what it is, sine hyperbolic x. So we can replace it by sine hyperbolic x. So sine hyperbolic x is equal to x plus x cube by 3 factorial plus x raised to 5 by 5 factorial plus so on. So here as you can see in the Maclaurin series for sine hyperbolic x there are odd powers of x, and in the Maclaurin series for cos hyperbolic x there are even powers of x. Ultimately we will have to remember these 4 standard series. So in this lecture we have discussed 4 standard series, that is first one is e raised to x, then e raised to minus x, then cos hyperbolic x and sine hyperbolic x. Thanks for watching this video. I will see you in the next lecture.